up here your morning work that we worked on. Division. And I have division with digital root, and I'm sure, hopefully, all of you are going, oh, what? I don't know how to do that, because that's what we're going to learn today. And if you've noticed, all of these division problems are what? What did you notice about them? What do they all have in common? They don't have any remainders, so they can be equally shared. Okay? Do you think I did that on purpose?
Yes.
I did. Because it's easiest if we start learning how to check our work with the digital root on a division problem when there are no remainders, okay? So, you should have on number 1, 72 divided by 3. Our quotient, our answer should be 24, right?
Yes.
Okay. I'm going to put a box around that just so that you really can see what my quotient is. And I'm going to show you on number 1 how to check your work with the digital root. You may write on your paper as I'm writing, and then you're going to try number 2 right here on the carpet so that we can see if we've got it. When I show you, you're going to go, oh my gosh, this is so easy, I cannot believe we haven't done this all year. Okay? So we know that the digital root is a quick and easy way, a fast way for us to check our work without having to do 24 times 3, right? So I'm going to start, and I'm going to say, I need to find out what the digital root of my quotient is, what my answer. Take those digits, add them together. 2 plus 4 is 6. Okay, is that less than 10? Alright, so the digital root of my quotient is 6. The digital root of my divisor, right, what I'm dividing by, is 3. That's easy. It's a single digit number. Okay, so if you want to write that on your paper with arrows, remember I always use the arrows to show digital root because arrows not really something, it's not a symbol that we use in math. It's not like an equal sign. Cody? Almost. Yeah, you're thinking. Okay, so Cody goes, oh, I know. You need to find the digital root of the dividend also. So you're actually finding 3 digital roots. What's 7 plus 2? 9. Okay, so I'm going to go take 9 and I'm going to circle it because the digital root of our quotient times our divisor should be the digital root of our dividend, which is the number inside our box. So I'm going to take 3 times 6. And I'm going to do that because it's the opposite of division, right? Multiplication is the opposite of division, right? So I'm going to say, what's 3 times 6?
18.
What's 1 plus 8?
9.
9. Do they match up?
Yep.
They do? Yeah. Okay? So I pretty much have to know right here, I'm going to lightly circle it, I have to know this digital root of the big number that I started with, our dividend. I have to know that before I can even move on. And then I'm going to take my digital root of my answer or my quotient times the digital root of my divisor. And I'm going to see if those numbers match up. Okay, so let's try it together on number 2 because this is new, it's different. If I have 512 as my dividend, the whole big group that I'm dividing by, what's the digital root of 512? Wasn't it? Yep. 5 plus 1 is 6, plus 2 is 8. Okay, and I'm going to circle it. This is what I'm hoping for. This is what I want to get, right? If my quotient times my divisor is 8, then I've got the right answer. Well, let's see. What's that digital root? That's easy. What's this one? 6 plus 4 is 10. Franklin already simplified it in his head to be 1. Well, guess what? Is 1 times 8, 8?
Yes.
Do they match?
Yes.
Then my answer is right. It's that easy. It's that easy. The reason that we use multiplication to find the digital root on division is because we have to know that it's the inverse operation. It's the opposite of division. Do you guys want to try number 3 on your own right now? Okay, so here's what I'm going to do. I'm going to freeze the board.
Miss Graves,
Yes.
could I see JT in the computer lab?
Yes, do you need Nathan also?
You can send whoever needs to do makeups.
Okay, Francis will be in at 9:30. Do you want him at that time?
Sure, that would be perfect.
Okay, so Francis, or Nathan and JT, why don't you just turn your clipboards over on the carpet?
Makeup's for what?
Start math first.
How many we put in?
I'd take your pencil and maybe get a piece of scrap paper, okay?
Oh, yes.
Yeah, you're going to rock it. You're going to do awesome. Okay, you solved number 3 while I solved number 3. Let's see if we can come up with the same answer, the same digital root, okay? Go for it. Go.
Whoa. Throw it out.
2 plus 4 is 6, plus 5 is 11. Okay, so start by finding the digital root. Remember, right here of your dividend, the number you're trying to share. Okay, then you're going to take your 2 numbers on the outside of that bracket, right? One is your answer, your quotient. The other is your divisor. And we're going to take those digital roots, multiply them together. We should have the same. Yeah, you got it. Yeah, you're on the right path. This one's trickier because you have to simplify the digital root. Let's see here. Alright, let's see if you got what I have. I should say you have what I have. That sounds better, doesn't it? Thumbs up if you have it. Pretty good. Jordan's like, I can't. It's hard for me to use my thumb with my cast. Is that what you got, Cody? Honestly, pretty easy. Feeling okay. Need a little bit more work. What do you think? Okay, so here's what you can do. On the last 3 problems, and of course we have to have them solved first, right? On the last 3 problems, you can choose. Do I want to work independently, because I'm feeling pretty good about it? Do I want to work with a partner, because I think my partner can help me? Or do I want to stay on the carpet and work with Miss Grace? Doesn't matter, whatever you choose, right? It's what you're most comfortable with. Right? Then, when you are finished, I want you to bring your paper to me, because I just want to check and see how you did it. Okay, so think about it independently. I'm going to work on my own. Put an I at the top of your paper. I'm going to work with a partner. Put a P. And if you think you want to work with me, put a NG. Independently, an I. Okay? And this is the first time we've learned this. This is okay. If you want to work with me, that's fine. Put a P. If you want to work with a partner. Okay? Feeling good about it? Who's ready to try it independently? Alright, go for it. Find a spot. Who wants to work with a partner? Good choice. Okay, find a partner. Anybody want to work with me? Oh, so fast. Nobody wants to work with me? Oh, that's alright. I'll come find you. Alright, let's see here. Put some water down on me. Let's see if we got it. Okay. see if you guys together, all three of you, could come up with a formula, a way to see if we can figure out that digital root. I'm going to tell you what. It's probably going to involve more than one operation.
You know how to do it?
I do.
Oh, I do.
Think so? So if you think you know how to get it to work for here, Emily, what would be the next step? What would be the next step? Try it on another problem. So if you think you can figure out for this one, let's try it on a little bit more difficult problem. 21 divided by 4. See what you can come up with. It's tricky, I'll be honest. Alright, Miss Ashley. Ooh, clear and concise, easy for me to see. Feel pretty good about it? Okay, you may be involved in the same group, because now that we know how to do that, we know that division is sloppy, division is messy, that's why we love it. Sometimes we have leftovers. Leftovers are often called, what? What are they called? The remainders. So if I have them like this, now how do I find it? See if you can come up with a solution, a formula with these friends on the carpet. Okay? See, you got to see if it works for the next problem, right, Emily? All right, gentlemen, let's see. Matt, I'm coming to you next, okay? Ooh, Jordan, we got to make sure that it's real clear and concise here, okay? One tip that I might have for you is that when you start dividing, so when I see how 72 divided by 3, we were able to put our 2's. But I see over here, see how we started counting by 35? Maybe if you looked in your head and you estimated like 35, okay, 35 is kind of close to 30, this would be 240, oh, so 240 divided by 30 is about, think about that in your head first so that you don't have to skip counting all the way down your paper.
7, 8, 9.
Are we adding it?
Okay, now you need to find the number.
Nope, let's take a look.
Okay, now
You ready for me to check, Elisa?
No.
Do you want to meet me on the rainbow carpet? I'll be there in a second. I gotta talk to Matt.
What's this number?
And Alicia, if you'd like to get started with that group on the carpet as it for a challenge, you can, and then I'll be done.
That 2 right there. What is it? 21. Okay, so 21.
Okay, so have we solved this one so far?
1.
We did this. Okay.
Okay.
I'm going to use my red pen so that's a little bit more clear, okay? What's the digital root? 245.
Now, multiply by this. What's
Is the digital root?
3? No, what's 7 times 3?
There you go. Simplify, right? So we need to know that this digital root times this digital root has to be what? 2. You got it. What's 8 times 7?
So 3 times 7.
Right, so get a 7 divided by
2
2.
plus 1 equals, now,
Is it? Why don't you go there to the number line,
by this.
and I want you to skip count by 7s 8 times.
You got it.
Okay? Or can you see it from here?
There it is. You got it.
You know what color factor 7 is? Bright orange? When you have it, let me know. What do you think?
I figured it out.
Alright?
Get that.
Impress me.
You have to add the remainder.
What do you mean by adding the remainder?
Because 2 times 3 equals 6. And then it's supposed to be 7. And then there's a remainder of 1. So you have to add that to make the decision.
Okay, so here's the thing. You're saying that we multiply here, and then we add. So that would be 2 operations, which makes sense. Does it work down here? Okay, so let's see. This digital root should be 3.
What's that number?
So 4 times 6.
Be
Here's the thing. It's all nice and easy when we have a remainder that's a single digit, but what happens when we have a remainder that's 25? Does it work then? What if we did, I don't know, let's try something. I think you're onto something, but we've got to try it again. I normally say that we have to try something 3 times to see if it works. Let's just we'll make it tricky. 116.
Involves 5 and 6.
We know that that can be divided by 2. What's a number that wouldn't be a factor? Where's 116 on a number line? 2. Okay, so maybe let's do like 8. What's 116 divided by 8? If this works down here, I think you guys
Yeah, so, and 2 plus 4 plus 5 is...
But you already know the code, so... I'll tell you what, Sergio. I didn't learn this when I was in school, and so it's kind of harder for me to wrap my brain around it as an adult. And I think that your mind power is going to be better than mine.
Anything else?
Alright, what'd you come up with?
Oh, wait, that's alright.
Alright, so now do we know what we need to do over here? Okay, Nader, I think you're doing a great job helping Sunny. Jordan's gonna work on number 4, and he's gonna do it all on his own, but then he's gonna check with you, okay?
Okay.
Alright. Which one are we on? Number 4?
Yeah, that was the check.
Do we have the answer for number 4 already? Okay, so remember how I was talking to Jackie and I said, when we get to big numbers like this, we need to estimate. It really helps us to start thinking about what we're going to do. Because I don't know about you, but do you want to be skip counting by 13 all the way down the side of this paper? No, it's going to take too long. Mathematics is the pursuit of laziness. So 13 times 10 is 130. Do we have 130 items to share? So we know that this number has to be less than 10. So maybe 8. So let's go over here. Let's try it. 3 times 8 is... And how smart for you to say 8, because in my head I was thinking, oh, there's going to be a 4 in the ones place, and look what's over here. A 4 in the ones place. So if we know that it's 8, I'm going to stop right here. Can you show me how we'd figure out the digital root? Check our work. 4.
Yeah.
5. Okay, let's circle that one so we know that it needs to be 5. What's 8 times 4? Is 32 a digital root?